want to continue with our class. We are looking at measurements. And significant figures. So we want to look at measurements and significant figures. So what is a measurement? A measurement is a quantitative observation. And as we are going to learn, for every measurement, you have a number, or we call it a value, and a unit. A measurement is not complete without these two parts. So if you report on the value, you have not done any measurement. So a measurement must have a value. You see, this part is the value, 4.18, and this is the unit. This is unit. Kilometers is a unit for this measurement. So let's say, for example, we have this, let's say this is a graduated cylinder. We're assuming that's a graduated cylinder. I want to measure a liquid. How do we measure it? So in science, all digits are certain, except for the last digit. Change the color to red. Except for the last digit, which is an estimate. All digits are certain except for the last digit, which is an estimate. Let's take, for example, we want to measure this volume using this particular graduated cylinder. So you see the level of our liquid? This is the level of our liquid. We put it here. But this liquid, if we have to measure it, read the measurement, you see, we'll write, all of us can see 87. We'll write 87. And you see, we can see 87.1 and 87.2. This is 87.2. We cannot say this, the volume of the liquid is 87.2 because it is in between 87.2 and 87.3. So what we have to do is to divide this part into 10 and get an estimate. Somebody can say it's 87.23. Another person can say it is 87.22. Another person can say it is 87.24. Some other person can see it as 87.25. If you notice, all of us here are seeing this 87.2 exact. All of us have 87.2 the same, but our last digit is different. That is what I mean by the last digit is an estimate. But all of us are correct. The main thing is that these three digits are the same. If the last digit is different, but anybody who writes 87.2 is wrong. Or 87.3 is wrong, because this measurement, based on what we are using, must have 4 digits, not 3. So, determine the last digit by estimating between the marks. Mentally divide the gap between the marks into tenths. Then estimate which tenth the indicator mark will be pointing towards. So it can be 87.23 or it can be 87.2. All of us are correct, but it must have 4 digits. How precise are our measurements? The precision of a measurement depends on the number of significant figures. That is why I said anybody who writes 87.2 is wrong. But anybody who writes 87.22 or 87.23 is correct. Because the significant figure is supposed to be 4, not 3. So the precision of our measurement depends on the number of significant figures. This is more precise. This is not precise. The least precise because it has fewer number of digits. So significant figures are the meaningful digits in a measurement. The last digit in any measurement is usually estimated and known as least significant digit. So in 5.342 centimeters, the digit 2 is the least significant because it is estimated. There are no absolute certainty in any measurement because of that last digit. The actual value of all measurements are always in a range. They are always in a range. So for example, if your measurement is 6, it means you're saying that it is between the range of 5 to 7. If your measurement is 6.2 millimeters, it means you're saying that it is between the range of 6.1 millimeters to 6.2. The more significant digits you have, the more certain is your measurement. Take note. The more significant digits you have, the more certain is your measurement. So, any analytical let's take an example. An analytical company in Trenton, New Jersey, designed 4 different instruments that can be used for density determination. In one experiment, the density of a liquid was reported using the 4 different instruments, and the results were given as follows. So they used the 4 different instruments and did the measurement. These are the results they obtained. 6 grams per milliliters, 6.125 grams per milliliters, 6.1 grams per milliliters, 6.13 grams per milliliters, and 6.1 grams per milliliter. So the question is, which of the measurement has the highest certainty? The one that has the highest certainty is 6.125 grams per milliliters because it has more digits. Even though 6.1 grams per milliliters appear 2 times, it doesn't make it the measurement with the highest certainty because its significant figure is only 2. But this one has 4 significant figures. We will look at how to count the significant figure. It has more digits. So guideline for counting significant figures. Let's look at the guideline for counting significant figures. If you have to count the significant figures, what are the guidelines? Guideline number 1, all non-zero digits are significant. So for example, this number, we have 2 non-zero digits, so it has 2 significant figures. This has 3 non-zero digits, so it has 3 significant figures. That's guideline number 1. Guideline number 2, interior zeros are significant. So this 0 here is significant. So we have 1, 2, 3 significant figures. These 2 zeros are significant, so we have 4 significant figures. Guideline number 3, leading zeros are not significant. So all these here are leading zeros. Even with this decimal point here, this is a leading zero. It is not in between non-zero digits. So it is not significant. So these are the ones which are significant. You see, these zeros are significant. This one is significant because it's after a number after a decimal point. That's why this is significant. So we have 4 significant figures. Here, all these, they are leading zeros. So we have only 1 significant figure for this number. Trailing zeros may or may not be significant. A trailing zero after a decimal point is significant, so this is significant. A trailing zero before a decimal point after a non-zero digit are significant, so this is significant. A 0 at the end of a number without a written decimal point are ambiguous and should be avoided by using scientific notation. For example, if I have to read this is a trailing zero, there's no decimal point. So it's not significant, so I have just 2 significant figures. But if I want this to be significant, I must write it in this form. So that I tell you that this 0 is significant. So in this case, I will have 3 significant figures. But if I write it here, it's ambiguous. I'll look at it and say it's 2 significant figures. So we have to be cautious with this. Some textbooks put a decimal point after the trailing zero if the zeros are to be considered significant. So if the 0 in 150 is to be considered significant, some textbooks write it like this, which tells you that we have 3 significant figures. So this is 3 significant figures and this is 4 significant figures. We want to look at exact number. A number whose value is known with complete certainty is called an exact number. We get it from counting objects. For example, 5 oranges, that's an exact number. 5 cups. Or from definitions, 1 centimeter is exactly equal to 0.01 meters. So 1 centimeter equals to 0.01 meters. This is an exact number. Or from integer values in equations. For example, 2 is an exact number. What I want you to take note is that exact numbers do not determine the significant figure of our answers because they are ambiguous. Infinity. Exact numbers do not determine the significant figures of our answer. So you cannot use exact number to say your answer will have 2 significant figures or 1 significant figure or 3 significant figures, because its significant figure is ambiguous. Exact numbers have unlimited number of significant figures. So let's look at some examples. Let's try and do some of this. How many significant figures are in each of the following? So you see, this number has a leading 0. And we say leading 0, their significant figures is not counted. They are not significant. So this thing will have 1, 2, 3, 4 significant figures. So 4 significant figures. This has zeros in between non-zero numbers, so we count them 1, 2, 3, 4, 5. So we have 5 significant figures for this number. This is an exact number. So it has infinite significant figure, ambiguous number of significant figure. So infinite because it is an exact number. In this case, we have 1, 2, 3, 4 scientific notation. We have written this number as scientific notation, so it has 4 significant figures. And this one, these leading zeros are insignificant, so this number has 1 significant figure. In this case, there is no decimal point, and this number is not written in a scientific notation. So the zeros, their significant figures are ambiguous. So in this case, generally ambiguous. So we can assume that it has just 1 significant figure. We are just assuming, but it's ambiguous. Then the last number is C, the decimal point. It shows that all these zeros are significant. So we have 1, 2, 3, 4, 5, 6 significant figures. So those are some examples to help us to determine significant figures of numbers. Now I want to go and look at significant figures and calculations. So now we want to see how we can handle significant figures in calculations. That is, when we carry out calculations, what significant figure will our answer have? There are 2 rules. Multiplication has a rule. Multiplication and division has a rule which is different from that of addition and subtraction. So when multiplying or dividing measurements with significant figures, the result has the same number of significant figures as the measurement with the fewest number of significant figures. We'll see what I am talking about. So for example, if we have figures like 5.02 times 89.665 times 0.10, we have to check the significant figures first. Then, before we even go into our calculation to do for our calculator to do the calculation, because when you do calculations in the calculator, it will give you many digits. But before then, you need to know the significant figure in which your answer will have. So 5.02 has 3 significant figures. 89.665 has 5 significant figures. And 0.10 has 2 significant figures. So before we even calculate, we know that our answer must be in 2 significant figures. Now, when we put our digits in calculator to do the calculation, this is what it gave us, 45.0118. But because we already know that our digit must be in 2 significant figures, we're going to cross out this and write 45. So our answer will be recorded as 45. Let's take this other example. Now is division. 5.892 divided by 6.10. This is 4 significant figure. This is 3 significant figure. So before we even start this, we know that our answer must be in 3 significant figures. So we do the division, we go to our calculator and do the division. And this is what we get, 0.96590. To 3 significant figures, we have to round up. And it will become 0.966. So that is why our answer is 0.96 that we are going to record. Now let's look at addition and subtraction. When adding or subtracting measurements with significant figures, the result should have the same number of decimal places. So with addition and subtraction, we are talking about decimal places before we can count the significant figure. So it's decimal places that control as the measurement with fewest number of decimal places. So this has 2 decimal places, this has 3, this has 3. So our answer must be in 2 decimal places. So when we do the addition, we notice that it came up as 9.214. But because our answer must be in 2 decimal places, we look at this, it's less than 5, we trash it. So we record this, 2 decimal places. Even though it ends up as 3 significant figures, but what controls is the decimal place. We'll take another example. We are subtracting. This has 1 decimal place, this has 3 decimal places. Our answer must have but 1 decimal place. So when we do this subtraction, we have 0.835, but our answer must be here. So we look at this value, it's less than 5, so we trash all this, and this is our answer. The next thing we want to talk about is rounding up or rounding down. Rounding is used to determine the correct number of significant figures. Rounding down, if the number after the place of the last digit significant figure is equal to or less, equal to 4 or less, drop all the digits after the last significant figure and leave the last significant figure as it is. So for example, we want to round up this number we want to round up this number in 2 significant digits, in 3 significant digits, and in 4 significant digits. Let's see how we are going to do that. If it's in 2 significant digits, we are going to look at this number. Yes, we are going to look at that number. That's true. If it's above 5, we'll convert it to 1 and add it here. But you see, it's less than 5. So we are going to cancel this. So our answer will be 2.4. If we want a 3 significant figure, clean this. We are going to look at this number. It's less than 5. So, oh good. So our number will be 2.43. And if we want a 4 significant figure, we'll look at this number. It's less than 5, cancel it. So this will be 2.432. That will be our answer. So that is how the answer will be. Let's round up. If the number after the place of the last digit, significant digit, is equal to 5 or more, drop all digits after the last significant figure and increase the last significant figure by 1. So for example, we want to round up this number to 2 significant figures, 3 significant figures, and 4. So if it's to 2 significant figures, we'll look at this. You see, it is above 5. Convert it to 1 and add it here, so your number will be 2.5. Excuse me. If we want to round it to 3 significant figures, what we are going to look at, we're going to look at this number. You see, it's above 5, so we'll round it and put it here. Round it to 1 and put it here, and our number will be 2.46. And if we want it in 4 significant figure, we'll look at this number. It's above 5, so we change it, convert it to 1, add it here, so our number will be 2.457. That will be our answer. So that is it. We'll take another example. This time is division. So for calculation that involve both multiplication and division and subtraction, do whatever is in the parentheses first. Evaluate the significant figure in the intermediate answer, then do the remaining steps. So this one, we have to do this first. So based on this, our answer must be in 1 decimal place. Then now we look at the significant figure and multiply this, then we get our answer. So we'll do this part first. Then so when you do this part, you see, we are putting a line here to show that our answer is supposed to be in 1 decimal place. So in short, we are supposed to have 2 significant figures. Then we do this multiplication, this is what we have. But already we know that it is going to be 2 significant figures. So now that we have done this, we will not do it before, but we'll just mark it there. Then when we do the final, we know that our answer will be 2 significant figures. So that's why the answer is 12. You see, your answer is 12. So let's do some fact checking on significant figures. Fact check. Perform the following calculations to the correct number of significant figures. We want to perform this calculation. calculation to the correct number of significant figure. So what we need to do, we want to do add. Please multiply all this before you divide by this. So this is 3 significant figure. This is 4 significant figure. This is 1, 2, 3, 5 significant figure. And this is 5 significant figure. But your answer must be in 3 significant figure. Then you take your calculator. 1.10 times 0.5120 times 4.0015 divided by 3.4555. So what you got from the calculator is 0.6521190653. But we know that our answer must be in 3 significant figures. Let me change the column. Our answer must be in 3 significant figures. So we look at this. It's less than 5. So just cancel everything. So you report your answer 0.652. So please try and do B and C. So that is where we will end with calculations and significant figures.